We are going to present our integrated project, which is entitled The First Nuclear-Powered Submarine Using Caterpillar Drive. I'm Hanis Suraya Binti Basaruddin Shah from CE Group 2.
Hello, my name is Zul Asnawi Zaiman. I'm from Chemical Engineering Group 2.
Hi, good morning. My name is Khor Jia Sen. I'm from CE Group 2.
Hello, this is Adnan Yahya from Chemical Engineering Group 2.
First, nuclear power, which is to generate high efficiency of work output as well as to calculate some specifications so that the submarine can move efficiently under the seawater. Okay, the submarine is powered by S7G nuclear reactor, which consists of reactor coolant, steam generation, and as well as pressurized water reactor. S7G is used by prototype for naval reactor designed for the US Navy, as it is to supply electricity generation and propulsion for warships in the late 1970s. The combustion needs a lot of energy, a lot of oxygen, so that they have to dive often to the surface to gain more oxygen for that. And third, we can reduce the cost of operating in terms of buying the fuel to generate the submarines. And then the last one is can reduce environment pollution. This is because the combustion will produce byproduct, and the byproduct will make the harm less for the surroundings. So we use nuclear reactor as nuclear reactor only generate heat to power up the turbine to generate power.
At present, there are two types of nuclear propulsion system in this world. One of it, which name is as conventional co-propulsion system, and then the other one is the nuclear propulsion system. So in the question, we are required to do the nuclear propulsion system. So in the nuclear propulsion system, as you can see here, it consists of two cycles. So the first cycle mainly deals with the heat exchanger, and the second cycle deals with the steam turbine. Okay, so in the first cycle, the nuclear reactor that will heat the water to produce steam. So the produced steam will go to the steam generator here. And the steam outlet of the steam generator will go to the cycle 2, which is the steam turbine. Okay, so this is the cycle 2. So the steam that enters to the turbine will produce work. So as you can see here, it has two steam turbines. Therefore, one of it is used for the internal system of the submarine, while the other one is used for the propulsion system of the submarine. So the steam turbine will spin, and then it will generate work to the submarine. Right, and then the outlet of the steam will go through the condenser, which it will be condensed and will be recycled back to the heat exchanger in cycle 1.
So basically, this is our steam turbine, and this is the condition of our inlet and outlet. For inlet, the state is saturated vapor, while for outlets, the state is saturated liquid vapor mixture. To find the enthalpy, we have to use the table A5 to determine our H1 and H2 value. Then we can proceed to find our power and our work done. Then this is what we get for our work done is around 25 megawatt. And next, we have to proceed to find the torque, and we assume that our RPS, which is the revolutions per second, is 6.224. Then by using this formula, we can get our torque. After we get our torque, we can proceed to calculate the torque coefficients, and we assume our diameter of our propeller is around 3 meters, and the density of our seawater is 1029 kg per meter cube. And then we can use the open water diagram to determine our thrust coefficient and our advance coefficient value. This is the open water diagram, and P over D is our pitch ratio, which we assume is 1.3. And then the touch coefficients that we get, we have to times with 10, and we get 0.6. And intercept point is points to our J value, which is 0.8. Next, as same things, we have to use our pitch ratio 1.3 and our advanced coefficient, which is 0.8, to determine our thrust coefficient 0.3. Okay, then we have our thrust coefficient. Now we can start to calculate our thrust. We can proceed to calculate our velocity by using our advanced coefficient just now, and the velocity is around 20 knots. Then, but this is the velocity that produced by the propeller. We still have to consider our drag coefficient, which is 0.45 on the surface and 0.09 during the submarine submerged. Then, by using this formula, we can get our velocity during the submarine submerged is around 27.98 knots. The velocity on the surface is 15.33 knots. Calculate the number of blades by using the total area of our propeller, and we assume the area of one blade is 1.85 meters squared. So we can use the total area of propeller divided with our area of one blade to get approximately 4 blades.
And the conclusion is we contribute in this project is to improve and enhance Malaysia fresh nuclear power design as it is to achieve beneficial conditions desired. From our calculation, we found that the work done from our turbine is around 25.62 megawatt. The surface area, we noticed that it is the half of submerged velocity. Thank you.